Okay, so we're going to start with problem number 12 of section 2.2, like the one I have up here. And essentially what we're going to do is graph this piecewise function that you can see in the upper right hand corner of the screen. So just give me a second while I write that down. So essentially what this is in a disguised form, it is the absolute value function. So this is actually another way to, or more formally, to write down the absolute value function. So we want to graph this, and I already forgot what numbers we want to graph it between. Okay, so what were those numbers? Let me go back over here. From negative infinity to infinity. That's a lot of numbers. Okay, so let's do that. Okay, so the first thing we're going to do is for the piecewise function, we're going to be graphing two different lines. We're going to graph this line when x is less than 0, and we're going to graph this line when x is greater than or equal to 0. So let's start out by drawing a number line. Okay, and over here I'm going to make a table. So first we're going to do the case number 1. So we're going to do case number 1 over here. And I'm going to put values for x. Now remember, for these values of x, I have to choose values that are less than 0. So here's my x, here's my f of x. Now the first one we can actually choose 0 to make it work, but it says less than 0. So we're going to go ahead and follow their rules. So we're going to pick 1, or negative 1, I'm sorry, because remember case 1 is less than 0. So f of negative 1 is going to be negative 2 times negative 1 is going to be equal to 2. And I can also pick negative 2 as a value because negative 2 is case 1 less than 0. And that's going to give me, if I plug it into my function, and again, I'm using negative 2 times the number I choose is what this case is. So it's negative 2 times the number I'm choosing is negative 2, which equals 4. So if I plot over here when x is negative 1, y is 1, 2. So I got this point over here. It's the point negative 1, 2. Go 1, 2, and then back 1. And then I have the point minus 2, minus 4, 3, 4, which is going to be this point right over here. And since it's a straight line, since negative 2x is a straight line, right, a straight line is anything in the form that can be written y is equal to m, some number m, times x plus b. Well, case 1, it's a piecewise function. Case 1 can be written y is equal to negative 2 times x plus 0. So in this case, m is negative 2, b is 0. Whenever you have that, a case like this, we can also think of the case where x has no power, isn't raised to any power, it's just a plain x, it's not an x squared or an x cubed. You can graph it by a straight line. You can just graph 2 points and then connect the 2 points with a straight line. So in this case, it's going to look like this if I just extend it. The reason I extend it all the way to 0 is because the line only goes to 0, right? We can start off as far to the left as we want, but we can only go for values of x up to 0, right? Negative 2, negative 1 stops at 0. Now, for the other case, which is case 2, I'll do that over here. And for that, what we're going to have is we're going to have x and f of x again. But we're going to pick values that are greater than or equal to 0. So I can pick 0 for my first value because it's greater than or equal to 0. And here I'm using this function definition. So it's going to be 2 times whatever number I choose. Well, if I choose 0, 2 times 0 is 0. And that's my first point. And then what I have is x is 1. And then my function definition, again, is 2 times the number I choose. It's going to be 2 times 1 is equal to 2. So my next point is that when x is 1, f of x is 2. It's going to be like this. Oh, maybe here a little bit. And if I just connect those with a straight line for the same reason, it's just a plain x. It's not an x squared or an x cubed or anything. So I just connect this point and this point, which is x is 0, y or f of x is 0. X is 1, f of x is 2. I just connected these 2 points, and that's my graph. So what I'm going to do now is I'm going to go and look back at the problem. And as you can see, answer choice D is the only one that remotely resembles what I graphed. I'm going to check my answer, and it's fantastic. Okay, that's all I have, and I hope they answered the question, and good luck with week 2. Thanks.